everyone. I have a problem for you today. We're given a figure with this graph, and we're asked to find the volume of the tetrahedron. Okay? So there's obviously a lot of different ways to find the solution of this. I'm going to solve this problem by trying to find it using triple integration. So if we try to set up the domain for the integral, we'll have a function of x, y, and z with x going from 0 to 1. So we know we're going to go from 0 to 1 for the x. And for the y, we can see that we're going to go from, we start at 0, 1, 0, and we go to, if you look at this line right here, you can basically represent y as a function of x1 half, because we start at 0, 0, 0, and then when we travel 1/2 of 1, we go up a fourth for y. So 0 to 1, we only go up a half. So that's the same thing as a slope of x over 2. So we can say 0 less than equal to y is less than equal to x over 2. And then lastly for z, we can represent that as 2 minus, so the highest we're at, we have 2. So, and then for the rest, we observe that when we get to 0, 1, 0, our z is 0. And when we get to 1, 1/2, z is 0. So if you picture that, that would look like 2 minus x minus 2y. And you can check that for yourself by looking at, where's that button? By looking at when we're at 0, 1, 0, if we imagine putting in 1 for y and x, 0 for x, you get 2 minus 2, which is 0. And then same thing with this point. So that's how we find the bounds. Now we're going to actually evaluate the integrals now that we know what to set up. So we're going to have a triple integral. And the order for this will be dz, because we have an x and a y term, and then dy, because we have an x term, and then now that our variables are gone, we can do that one lastly. This is actually blank. There's nothing that goes in between the integrand and the differential. So all we have to do is plug in now. 0 to 1, 0 x to the half, and 0 to 2 minus x minus 2y. So I'm going to get started on that now. So for z, we have nothing. So constant of 1 to be technical. Yeah, because that's actually what's there. So we're just going to have z. And then we're going to evaluate z from 2 minus x minus 2y to 0. So if I do that, that means I'm just plugging in 2 minus x minus 2y, so that I'm left with 2 minus x minus 2y. We don't get anything for 0, so we can just ignore it, and then we can put dy dx. Okay. I'm going to move down slightly and continue here. So integral 0 to 1, and if we differentiate with respect to y, we get 2y for the constant 2, negative x squared over 2 for the x term, and then minus y squared. Oh, mistake on this one right here, actually. This should actually just be negative xy. So don't do that. Just put negative xy. And then evaluate from x over 2 to 0 and dx. So if I do that now, that means I get 2x over 2, which is just going to be 1x, and then minus x squared over 2 for the next part. And then you have minus x squared over 4. And then we evaluate that from dx. So if I integrate with respect to x, I have, this should just be x, so that's going to be x squared over 2. Then negative minus x cubed over 3 minus x cubed over 12. And then, let me get rid of this stuff here. And then we're gonna plug in no integral since we already integrated, but we're gonna evaluate from 1 to 0. You get 1/2 minus 1/3 minus 12. 1 over 12. And then, so 1/2, write this all with the common denominator. That's gonna be 6 over 12 minus 4 over 12 actually, and then minus 1/12 again, until we get 1/6 for our final answer. And then times 2, because we should actually have 1/3. So that's all I have for you guys. Have a good day.